Welcome to the partial fraction decomposition lesson. It's been commonly perceived by pre-calculus students that apparently partial fraction decomposition is too difficult. In this video, we will, debunk that and we will see. So, in this first problem, we see there's just linear factors, right? So that means that it's just going to be a letter. So it's going to be a x minus 2 plus b x plus 1. So now we are able to cancel out these values in the denominator. And so one of the ways I like to think about it is sort of just get rid of the things you already have and replace them with things that you don't have, right? So 7x plus 3, it would be equal to a x plus 1 plus b x minus 2. You get x equals negative 1. And this is where you start to kind of problem solve. You set one side equal to 0. And so that would get negative 4 equals negative 3b. And we all know that negative and negative gets you a positive. So b is equal to 4 over 3. So how do you find a, right? So x is equal to 2. That would get one side to 0. So that would be 17 is equal to 3a. And so a is 17 over 3. And so now you can plug it back into your little formula that you made, right? So 4 over 3 x minus 2 plus 17 over 3 x plus 1. So let's get to the next problem. So this next problem here is a little bit tricky, and you kind of get thrown off guard when you first see it. It seems like a quadratic, so you automatically go into to ax plus b. But in this case, it's really just repeating of a linear factor. So it's actually going to be x minus 1 plus b x minus 1 squared. Doesn't make a difference. And so obviously now you just have to sort of solve. So you're missing 1 x minus 1, but for b you're not missing anything. So it's just going to be b. So you can set x equal to 1, and that gets rid of a. So now you're left with 10 is equal to b. So that's out there. So now we don't really have another value that we can plug in for x to kind of isolate another variable. So all we can really do is just plug everything in. So 4x plus 6 is equal to ax minus a. Better way to phrase that was to distribute. So in this case, I can just tell that a is 4. And if you're not going to believe that, I could also prove it in another way. So these are corresponding, so those are going to be equal. But if you were not to believe that, so negative a plus b is equal to negative, so b equal to 6. And so you already know b is 10. So negative a is equal to negative 4. A is still going to be equal to 4 in the long run. So that just goes to show that these values are going to be corresponding to each other. So if you can't find a value where you don't have a 0 that you can use, just do a bit more steps and it will get you to the right answer. So this next problem we all see. Now this is an actual quadratic, so the first one's obviously a linear factor, but the second one is going to be a quadratic. So now this is going to be 3x squared plus 2x plus 5 is equal to x squared plus 4 plus bx plus c x plus 1 And so you kind of see that there aren't really any ways to get rid of just all of the factors that lead you to one factor. So you sort of have to make sure that there's no choice. So you just have to you have to distribute everything. So 3x squared plus 2x plus 5 is equal to ax squared plus 4a plus bx plus cx plus c. And so you just have to sort of sort these. And you can already tell that a is 3, sorry, because it's corresponding to each other. So a is already 3. So now you have to sort these. So bx and cx. So b plus c, these are going to be x's, right? And so it's really important to see. However, we don't really know any values yet with x because we don't even know inside that function, right? So c would be 5. So that gives you a huge advantage because now it's going to be b plus 5 is equal to 2. So that makes it really easy because you already know a, which is 3, and we just found out that c was equal to 5. So the only thing now is b, right? So b would be -3. So now it's just going to be 3 over x plus 1, and then minus 3x plus 5 over x squared plus 4. So that would be that equation for the partial fraction. And this last one here is really just going to be a long division problem because there aren't really, you have to get it inside a long division problem and then you do the partial fraction. So x to the third plus 2x squared plus x plus 1, x to the third, and then you do plus x squared. Again, you want to be able to match your first term. So that's just going to be x squared plus x plus 1. So you have x squared. And then you have x. So both of those go away. You're left with one remainder. And so x plus 1. And then you have 1 over x squared plus x. So now it's really just about getting that out of the way. So you could factor this out. So you could say 1 over x plus 1. So that makes it really easy. And so that would just mean that 1 over this value here would be a over x plus b over x plus 1. And that's your typical partial fraction. So 1 is equal to a x plus 1. Again, what you're missing, right? So x would be -1. So 1 is equal to -1b. 1 is equal to -1b. b would be -1. And then when x is 0, again, 1 is equal to 1a. So a would also be 1. So in this case, it just so happens to be that x plus 1 is also adding upon 1 over x plus, it's going to be minus 1 over x minus 1. So again, partial fractions are sort of this kind of this. You have to make sure you utilize everything in your toolbox. And you might not use all of these tools, but you need to make sure you have all of the tools, right? And because if you're missing a tool, then you're not going to be able to solve a given problem. So appreciate you coming and stopping by and watching this video. So yeah, see you in the next one.